What's up, ladies and gentlemen? This is Danny Mathematics again. I want to go over example 2 of how to find the nth term of a geometric sequence. Once again, I'm going over example 2 of how to find out the nth term of a geometric sequence. So in example 2, we have this sequence of 2, -10, 50, ... and then we're trying to figure out what would be the 14th term within this geometric sequence, okay? Now, once again, ladies and gentlemen, we know that the formula to finding out the nth term of a geometric sequence is an, which is an represents the nth term. In this case, it will be the 14th term, equals a1, which is the first term, times r, which is the common ratio, to the n minus 1 power. And n represents the number of total terms, okay? So let's just go ahead and get started. All right, we know that an in this particular case, guys, is going to be a14 because that is what we're trying to figure out. We're trying to figure out what is the 14th term. Okay, all right, a1 in this particular case, 2 will be a1, which is the first term within the sequence. Okay, 2 will be a1. Once again, that is the first term within a geometric sequence. Okay? The next part, guys, will be the common ratio. Okay? The common ratio, which is R. Okay? Once again, for me to go from 2 to -10, I had to multiply by -5. For me to go from -10 to 50, I have to multiply by -5. So my common ratio is -5. Okay? And then after that, guys, of course, the number of terms in this particular case would be 14 because we're trying to find out the 14th term. Okay, so right now, ladies and gentlemen, we have all the parts that we need in order for us to figure out what would be the value of the 14th term. Okay, so now let's just go and plug in into the formula. I have an equals a1, right, times r to the n minus 1 power. Okay? So now, ladies and gentlemen, all we got to do is just plug in into the formula and use a calculator to solve it. So an will be a14. Remember, that's what we were trying to find. Equals a1, which is the first term, is 2. So it's going to be 2 times r. R in this case would be -5 to the n minus 1 power. So n will be 14. So it will be 14 minus 1. Okay? So this is how it should look once you plug all your values in. All right, let's simplify before we actually solve. I still have a times 2. 2 times -5 to the 14 minus 1 is 13 actually. Okay? So we're going to simplify that to 13. Okay? Now, once you plug that into the calculator, you will get that -5, and you have to do the exponent first. Remember, order operations, PEMDAS. -5 to the 13th power is... Oh, that's a pretty big number. Let's see what it is. That's this is 3,125. That's a pretty big number. All right. Then you multiply that by 2, and then you would get this number. Which is a 2, 4, 4, 1, 4, 0, 6, 2, 5, 0, boom, boom, and boom, 1,000 million. So that's -2,441,406,250. Okay, that is the value of the 14th term. This will be the 14th term. So once again, ladies and gentlemen, this is how we find out the nth term of a geometric sequence. Thank y'all for tuning in, and I will come out with one more example moving forward. Thank you. Talk to you next time.